Hello, dear students. Today I will continue to provide for you lecture materials on medical informatics and biostatistics course. For those students who join us for the first time, my name is Andriy Semenets and I am Associated Professor of Medical Informatics Department. The title of today's lecture is Mathematical and Statistical Data Analysis in Medicine, Biostatistics Methods, and Evidence-Based Medicine. In fact, this topic is too broad, and actually I will be able to provide only some introduction and basis on it. Other hand, you will meet a question related to biostatistics within other courses during your education in our university. Let's proceed with lecture plan and objective. There are four main questions for this lecture. First of all, some short recap about usage, not only Microsoft Excel, but any spreadsheet application to perform various mathematical calculations. And other three questions represent core of lecture, especially usage of spreadsheet application to perform statistical calculation and hypothesis testing. Also, we consider question regarding how to perform correlation or regressional analysis by using spreadsheet like Microsoft Excel. And I will try to provide some introduction about optimal management task solving. Probably that will be impossible to cover all this question within single lecture time interval, and it only means that two lecture session will be spent for this. Okay, before we will actually move into statistical analysis and statistical calculation, and especially hypothesis testing with using of spreadsheet application, from my experience, we need some recap and introduction about basic calculation. So let's start with features of spreadsheet application like Microsoft Excel, which could be used to perform mathematical as well as statistical calculation. So I will show structure of spreadsheet application in Excel, then function and usage of it, and how to use equation wizard if necessary. In general, spreadsheet application decided itself to perform various types of calculation. And its major aim and major purpose of spreadsheet application, it's not keep tabular data, but also it's provide calculation itself. And here we have like two general type of calculation, which could be which could be implemented with spreadsheet application, like simple calculation, above, and composite, which consists of multiply arithmetical operators combined with various functions with multiply arguments below. As you can see here, one of the specific features of Microsoft Excel, it's partial localization of function. Here, as you can see, we have abs function, which is plotted in English, and we have square root function, which is localized on the Ukrainian and Russian version of spreadsheet application. It's like a little bit uncomfortable, but user have to be aware without it. And also, as you can see, we can combine any necessary numbers of function within single equation. Let's consider anatomy of formula and function in Excel a little bit more detailed. Especially, I will concentrate on usage of function. So any equation and calculation in spreadsheet has been started with equal sign, which had to be followed by a list of by constant mathematical operators and function along with argument. So function tells Excel to perform specific set of operation on cell or array we are referred to. And as function in Excel formulas represented by function name, which typically some statement, sentence, word, and followed by a list of arguments in brackets, at least single one arguments required. Different function require a different number of arguments. Sometimes it could be only constant values. More often, especially in statistical calculation, arguments have to be arrays or list or ranges. Elements in arrays have to be separated by colon, and arguments separated by comma or semicolon, depending to local settings of spreadsheet application. And again, below we have a little bit more complex example with logical function. And every time when you enter equation in which contain function into Excel spreadsheet, you will have hints with special hints bar, which provide for you syntaxes of current function as well as active argument you have to provide. In addition to conventional function, Excel and our other spreadsheet also supports arrays function. So here is we have like instead of single destination point, single arguments, we provide array, and it's upward not for single cell but for also range as well. So about a few words about arguments of spreadsheet function. It have to be constant. It could be constant that text or number values that it's inserted directly into equation or function. But most common approach it's access available data. When we have some data collected within your spreadsheet worksheet, so it's natural, it's obvious to use this data and does not retype it. And in this case, you have to refer specific cell or cell range by relative or absolute reference. So here is, in case of relative reference, we use column combination of column label row number. In case of absolute reference, we can prepend our statement, our address with $sign, and in this case we can refer specific cell, as you can see, or column, or only row. So here is below given these cases. Also, especially in statistical calculation, we need to deal with arrays or set of data, and difference that within to define array we have to provide only its boundaries, like left top corner and right bottom corner for square matrix, or beginning end for vector, delimited by colon. Like here, I give an example above. And if set, we must list exactly each one single element delimited by a semicolon. So, example given below. All these things is actually minimal requirements and techniques to implement it. It's minimal requirements to be able to deal with mathematical statistical calculation in spreadsheet. For us, available insert function wizard button in all version of spreadsheet, which actually only guide us through 2 steps which first allow search or select necessary function by search or by category, and on step 2, dialog assist us to pick necessary arguments for function with choose button or direct access to spreadsheet. Unnecessary but helpful things for the beginners. And here is, despite our changes within years of existence of spreadsheet application like Excel, insert function wizard almost did not change for those decades and still consists of these 2 dialog box. First, allow for you search or pick function from recent list or from categories. Second, give for you access to list of arguments, provide ongoing hint about results of calculation and results of arguments, actual arguments and results of function has been pre-calculated displayed here. Okay, after this introduction, we can move into a question which is related to statistical analysis itself. And I think to time I will try to switch to spreadsheet application to Microsoft Excel to provide some useful examples. When we consider usage of spreadsheet application like Microsoft Excel to perform statistical analysis, so we have major 2 aims. It's using it to retrieve descriptive statistic assessment and perform statistical hypothesis testing. So that's question I will cover. For sure, it's possible to perform other kind of statistical analysis with spreadsheet, like as I mentioned, regressional analysis, identification of statistical relationship between variables, but it will be goal of third question of this lecture. Let's start with definition of brief definition of statistics and review what is descriptive statistic itself. So, by definition, statistics is a branch of mathematics which deals with collection, organization, analysis, interpretation, and presentation of various data. In fact, is independent scientific area for studying and research now. In medical statistics, we deal with application of statistic principles to medicine and health science, and which is including epidemiology, public health, forensic medicine, clinical research, and actually that it's those subjects when you will return back to statistical study, statistical calculation during your education in our university. And it's also subfields of statistical science itself for decades already. And here is important to notice difference between probability and statistics, despite that very tightly connected. Probability is measure of likelihood that event will occur or not, and studied under probability theory, which is also a branch of mathematics and scientific area for studying research. Statistics and probability are 2 related but separate academic discipline. In statistical analysis, we use probability distribution of 2 topics often studied together. Actually, here is chart below show a key difference and similarity. For probability, we are first given model and want to retrieve data. In statistics, typically we collect, especially in medical statistics, we typically already collected data, observed it during scientific experiment, and or collected from our healthcare practice from patients, and we want to create some sort of statistical model, mathematical statistical model to describe data in general. necessary statistical key points and brief definition of statistical terms and elements. So statistic itself lie into measure of sample characteristics, sample or population characteristics. It would be much more correct to tell this way. Where population contains all members of some groups that is objective of our studying. For example, it could be our students in the university or our citizens of some country or even whole population of our planet. But it's hard to deal with and extremely difficult to measure such large group of subjects for studying, so practically we every time deal with samples or a subset of population. For example, second year students, it's sample which represent our population, population of students in our university and so on. In the same way, particular group of the second year students of foreign students faculty, it's sample which represent whole population of second year foreign students. In both my examples, representative characteristics of samples significantly different, but it's a little bit out of scope of this lecture. Also, variable dependent and independent variables, that things we deal every time in statistical analysis. So variable quickly define as characteristics that can form different value from one observation to another. And during our scientific experiment, we can have control on the independent variable. For example, we can decide time interval for observation. In this case, independent variable will be time, or we can select persons who will be included in control experimental group. So in this case, independent variable, it will be subject of studying itself. And response variable can't be controlled. We only measure interesting for us characteristics like human vital parameters, human or animals vital parameters, or register some changes through time. For example, when we're recording ECG electrocardiogram from patient, time is independent variable, and measured electric potentials become responsible variables. Or also term dependent variables could be used. So in case if we measure population, we deal with like independent response variable will be related to whole population. When we perform our experiment on sample, term independent dependent variable will be referred to our sample data for sure. It's very important to get through and remember main type of variables. So our kind of data can be split in two general groups, like categorical or qualitative variables and quantitative variables. Categorical also have to be descended split in three groups, like binary, which have only two values, nominal, which contain more possible categories values, and ordinal, when we can add some sort of order to our data set. And with quantitative variable, we deal with discrete and continuous variable, which discrete represent as numerical values and continuous uninterrupted. Also, it would be fine to remember then when we talk about some computer data processing, even if origin of our data is continuous variable like time. Practically, when we measure some characteristic for a particular time moment, it's turned instantly into discrete value. If we will look more detailed about categorical variables, so we can identify some categories which could be seen as treatment group, exposure, disease status, and we can identify binary or dichotomous variable which have only two values, like did live, yes, no, treatment placebo, and so on. For nominal ordinal variable, major difference that nominal variables represent named categories where order does not matter. It's like blood type of patient or marital status or even patient number itself, patient name. Other example of nominal variables is like city name, country name, and so on. So all these things, all this data have been related to nominal variables, and so we, in particular case, we only say that specific value, particular value, or equal, given, or not, and no more. We can't compare like greater or smaller. We can't do any operations. With ordinal variable, we introduce order and sequence in our analysis. And for example, we can classify cancer into levels. We can also, for example, base order, we can add the, for example, day of week. It's also ordinal variable. Similar way, yes, for sure. Students rating letter grades A, B, C, D, F. It's definitely ordinal variable, and actually even conventional marks which I assign for each student during our practical classes, which is represented by numbers, it still must be considered as ordinal variable. So that's our marks, uracil from 1 to 12. Scientifically, it's represented by ordinal variable because different teacher will provide different assessment, will issue different marks for you, and here is reason. In contrast, quantitative variables numerical by their nature, and we can perform kind of arithmetical manipulation, like we can perform counts, so we can perform summarization, difference, perform multiplication, and so on. Discrete number represent limited set of distinct values, such as whole numbers. Most of medical statistics measure refer to us in form of discrete numbers. Numbers of any kind of diseases, no matter it's AIDS or COVID, in a particular country around the world during year, or just positive COVID test for today. So all this, it's discrete numbers. So on, and continuous variables contain any number within a defined range. It's like age or blood pressure or so. So it's continuous by their nature, but when we perform observation and registration, we retrieve some fixed value, so it's turned into discrete when we register age at any point, or when we perform registration of blood pressure. So we got discrete value for this particular moment in time. Okay, now move into descriptive statistics. So actually, major rules for not only statistics but any kind of analysis. It's like every time try to use common sense and before perform any advanced analysis, try to visualize data to recognize possible tendencies, trends, and so on. It can give for us hint for further analysis. That things with common sense is, from one side, it's very obvious. From other hand, with modern, like very easy availability of various computer information technologies with extremely powerful personal computers and mobile devices right now, we got unique chance to perform any kind of analysis almost any time. But major problem that despite we have technical capabilities to perform some analysis, it's not in our case have any sense. So we can very easily fall into situation when we perform lots of calculation which will be useless, and the results that we obtain will be absolutely non-informative, or even worse, it will be mistake but by themselves. But technically we can get such achievement, and it's significant problem. Okay, if we refer about, first of all, every time, first step of another data analysis, it's visualize data and determine possible behavior or relationship between data. Choice of chart every time depends to data type, and here is become very important to understand that major two data types, like categorical continuous type of variables, and distinguishing aptly proper type of chart which fit with specific data type. For example, if we have at least one categorical variable, typically independent variable, bar chart, linear chart, or similar solution will be very useful. Other hand, if we deal with continuous variables, so both independent, dependent, both, or even if we have more than two variables, our fit are continuous. We have to use like solution statement leaf, box plot, histogram, scatter plot again, and similar things. More details on this given in practical class material for practical class number 6, which is referred to visualization of biosignals. But right now, just some quick review. For sure, most often chart type, it's bar or linear charts, which is used for categorical variables to show frequency and proportion in each category. So here is in definition we sign that's our independent variable, or variable which lie along x-axis is categorical or non-numerical, even if it could be depicted in form of digits. Origin of this data is categorical, is nominal, not numerical. I mean, we're talking about like patient number or patient name or something similar. practically it could look like this one. So we display number of patients which get some specific shock index. And here we have 10 levels of shock and number of patients that struggle with, that suffer from this level of shock. So again, it's nice example that from things that I already said, we have x-axis which is signed with numbers, but all this category are nominal, categorical and ordinal, because order now have matter. 10 shock of 10 levels, it's almost deadly. When fast level, it's like a little bit disturbing and so on. And each one bar represents number of patients facing this level of shock. If we turn into continuous variable, so for the first time I will introduce chart types that maybe you will never meet. It's like stem and leaf plot, which is actually very relatively old way to perform pen and paper analysis. Useful, but useful only for relatively very small data sets. In this case, we can decide a part of data series into leading digit like stem and trailing digits like leaf. And here is example how we can depict age of participant of our, for example, statistical experiment with stem and leaf, and actually we would say something very similar to bar chart, but which is represent categorical data. Regarding box plot, I will show example later. And now we immediately turn into histogram as actually most common way to visualize continuous variables. And the purpose of it is provide raw assessment of probability distribution of given variable by depicting frequencies of observation occurring in a certain range of value. In this case, we have assigned that we have our independent variable continuous. Our x-axis is represented by continuous variable. For example, in this case, it's talking about like statistics for a report when we have arrivals per minutes, or okay, in another case, it could be statistics for emergency hospital department in time of COVID pandemic, when we have like endless queue of patients which are like in few every minutes. So independent variable is continuous, and we have dependent discrete variables, number of patients which is arrive in during particular time interval. So this time x-axis has been split into intervals. In this case, it's like half of minutes, and provide a frequency of how many patients arrive or during, for example, if we consider emergency department within this given time interval. Again, it's not number of patients, it's frequency of how many time often such events that, for example, one patient per 11 minutes, like there is nothing, not anyone, but 11 and 30 seconds, it's happened once. and typical arrival rate it's about 3 and 30 or 4 and 30 seconds minutes. Again, it's frequency. So with descriptive statistics, we can provide some set of assessment for our data set, for our samples, as it we talk about population data set or sample data set, and we can split into our descriptive statistic measures. We can classify in few groups like central tendency measures, variation measures, quartiles, shapes. Actually, this list is not finite. We can add the more additional descriptive statistic parameters, which is not very often, which is used not such often as listed here. And check what kind of measures could be used for describe particular data. Again, it depends to data type. If we talk about interval level data, measures central tendency, variation, common descriptive statistics. So again, we are talking about discrete or continuous variable after being digitized. Measures of central tendency describe series data with single attribute. Measures of variation describe how widely data elements vary around this center. So actually, center can give for us, can allow for us even replace whole data set with single value, which will be most common for this data set. And variation give for us additional value, which provide information how other data deviate from given central value. Various standardized scores combines both central tendency and variation to single description, comparable across different sample with sample or different units of measures. Typical standardized score adds mean with mean error. In case of nominal ordinal data, proportion are common methods used to describe frequencies as they are compared to total. Technically, here is we have most common descriptive statistics which allow for us measures of central tendencies like mean, median, mode, and other. And here is we have example of variable, for example, age of patient, so known as X. We have only very small data set which consists of 7 observations, so it's sample size 7 in this case, or number of scores or cases, or as well sample size. Here is also given sum and average when we divide sum by number of scores. And median, it's like average of middle point of our data set when half of score is above and half below of it. And mode, its value in our data set, which is repeated most often. So why do we need several central tendency assessment? Because possible that could be affected by extreme value or outlines. And here is example about how easy mean or average could be affected and change it when we add only single one value, which is outlier. So we move 1 from 5 to 10, and we got absolutely another average for our sample. But in this specific case, median will not be affected and remains at the same value. So combination of mean and median reported by specific data set could give for us information about shape of distribution, about presence of outliers in this case. When with dispersion or variability, we give first information about spread of variability of data value. So on chart we have two different histogram of two different data set, distribution of different data set, not histogram, sorry, distribution of two different data set, visual representation of distribution, which both symmetrical, so their central tendency exactly the same. We have like mean, mode, and median exactly the same, but as you can see, shape significantly different, so they have significant difference in variability. And criteria like range, interquartile range, variance, standard deviation, coefficient of variation could help us to provide. From all this, most interesting is quartiles, which we separate our data set in 4 equal quarter, and 25% on data will have to belong for each of this quartile. Typically, in statistical analysis, interquartile range been used as difference between first and third quartile. So here is shown horizontal box plot, and actually this time I am introduced box plot for the first time, which show for us actually interquartile range with box maximum and minimum like representative for first and fourth quartile, and median value at the center. And here is above real data, how it's aligned in our case. So few parameters have to be used to could be calculated to represent variability of sample or population, and simplest is range. Difference between maximum and minimum. Interquartile range I already presented. Other assessed conventional assessment and variance and standard deviation, which is in fact square root of variance, and variance actually square deviation between individual scores of mean, and largest variance, more variability there is among scores. In standard deviation, in contrast, it's provide representation variation among scores that's directly compared to the real scores. Here is given techniques how to achieve all this in conventional statistical calculation, but fortunately we no need such difficult calculation to be performed manually. Actually, I have such experience. I did it 25 years ago, but right now it's not necessary. We can order our spreadsheet application to perform this analysis for us, and I will show it in minutes. Okay. So standard deviation, again, have variability characteristics like standard deviation could help us in assessment of our data set. Here is given 3 examples for 3 different data set. Red point represent value which recorded in data set. All these 3 has the same mean value, but extremely different standard deviation value. And here is we can see how data spread and how it depends to value of standard deviation. And finally, box plot. It's extremely nice chart type, scientific chart type, which can give for us maximum information about our data set in one representation. When we have when both maximum minimum interquartile range will be presented, outliers assigned, median also depicted in one value. So we have exactly the same representation of past chat about how many patients suffer from specific shock X index, which is in fact visualized with box plot. Very useful box plot, especially if you want to compare multiply variables together. Just for seconds, statistical notation for various descriptive statistic parameters, sample population mean, it's a different Greek-Latin characters has to be used, and a few function name from conventional spreadsheet application which could help us with calculation of descriptive statistic parameters. And I think it's time to move into spreadsheet application for a few minutes to practically present how we can achieve something with descriptive statistic. And here is we have like two data sets, some patient split into group, observed some no matter which one, characteristics we obtain from patient. First of all, if you want just display visually this data, it's have to be obvious that patient number become categorical variables, but measured data for sure is different discrete value or interval data. So if you want to visualize behavior of group A, B measures regarding to patient, it's just simple case to insert. We can insert conventional line chart or bar chart, no matter, and patient number or name have to be used as x-axis labels. But if you want to compare, these two variables, correct way will be is to use scatter plot. We can and especially, so here is will be XY scatter. XY scatter with only with dot. In case if we have time instead of time interval instead of patient. So another chart become informative. We can consider it as even biosignals. So in this case, it's useful XY scatter plot with segments or straight line. So here is we have, in case if we have independent variable nominal, or if our independent variable is discrete, we will use another approach to build chart type. Okay, now, and I will back to again patient number. Now how to create specific statistic chart in modern spreadsheet. These features work only in modern Excel, never than 2016. Here is we have histogram and box plot chart. So in my case, I can create a histogram and even I can adjust my I'm sorry, not chat area, but axis with number of bins, number of intervals will be separated my data set. And here is I can compare group A with group B by using histogram. Again, the same way. B, and I will adjust the same number of bins. So here is we have something much more similar to normal distribution, which I will talk in seconds about it. And if I want even better representation, let's say, okay, sorry, and fine to use labels on histogram. Here is I have interval, for me given interval of observation as x-axis and frequency of how many values in my data set, in my samples, fit into given interval. And to finalize with this, I will also compare both variable with box plot. Would be fine to add the sum notation here. Okay, even numerical value. And okay, I can add the grid lines, legends, enough. So, as I said, box plot provide for me maximum available information right now, and even I can give some answer about presence of outliers, about difference. Instantly I can provide answer about maximum minimum value, where we have greatest smallest median and smaller greatest deviation from median for this pair of data set. And to continue to finalize with descriptive statistics, I will calculate numerical representation of descriptive statistic by using data analysis toolpack. For this case, I will select my data range. So my data are available in columns, my samples. First row I have labels, what I want to calculate, summary statistical confidence interval, and output range, okay, have to be new worksheet. So for me, given numerical assessment, numerical measures with common descriptive statistic parameters, like for both my samples, group A and group B, where given mean, standard error or mean error, they are presented in pair median, mode, standard deviation with variance, and some shape assessment tool. So as you can see, basic statistics, visual statistics, as well as numerical assessment could be obtained with spreadsheet almost instantly without any significant problem. But to do it properly, we have to be aware about data types and choose, especially if you talk about chat, choose proper data type, proper chat type depending data type. Now time to introduce, time to move into hypothesis testing, and time to introduce term of distribution of data set, which is listing or functions showing all possible value of intervals of data and how often they occur. Especially frequency distribution, which example shown at left side, is grouping data into mutually exclusive categories showing number of observations in each class. So classes could be typically organized in sequence. So here is example of frequency, and previously it was shown for shock index, but only in chat, not with numerical data set. There are multiply sampling distribution used in hypothesis testing, but most common is normal distribution, which it present how data would appear if we create frequency histogram where x-axis represent value of scores in distribution and y-axis represent frequency of scores of each time. And most scores will be similar and therefore will group near the center of distribution. Some scores with unusual values will be located far from center upper distribution. So here is general depiction of ideal distribution when we have which fall with 68, 95, 99.7 rule, where like 68% of data aligned within one standard deviation from mean value from median, then 95% lie with between two standard deviation from median, and almost all data lie within 3 standard deviation of center distribution of median. So it's so covered 68, 95, 99, 6-point rule. And actually it's approach which allows to identify is it our data similar to normal distribution or not. Margin properties, as I said, it forms a symmetric bell-shaped curve. It's separated by half at the midpoint, so mode, mean, and median have to be equal. Also asymptotic to the x-axis, and follow given rules which I already mentioned. In reality, when we collect our data during scientific experiments, it's very rare case when our data set fall into ideal normal distribution. Most often we will have like shaped or skewed our data set left to or right from ideal symmetric case. And it's also important to provide some sort of assessment of how it's different from normality. Term of normal distribution very important in process of performing hypothesis testing. In general, statistical hypothesis testing used to establish conclusion where the difference exhibited by random samples can be inferred to the population from which samples originate. So, if we collect some data, for example, about students of to a particular group of students, can they be seen as representative for all students of university, or, for example, all students in a country or even around the world? So, is it possible to use data obtained, assessment obtained on samples? It could be referred to general population. Some set of principles and steps issued to be and must be used during performing hypothesis testing in statistical data analysis, especially assumption that samples must be randomly selected, samples estimated compared to underlying distribution, the sample size, sample distribution, and probability that sample estimate reflects population parameters. And also, we have mutually exclusive comparison samples. Data characteristics must be statistical. Data characteristics must match statistical techniques. So again, we come to problems that when we want to apply particular methods for statistical hypothesis testing, we must take into account data type. And we have specific methods which could be applicable for interval ratio data, like discrete or discrete and continuous, like well-known test statistics, Pearson correlation, ANOVA, regressional analysis. In contrast, when we talk about nominal ordinal data, difference proportion, chi-square, related measures of association will have to be applied. Again, depending to data type, we must select proper methods of hypothesis testing. If we will try to create something like step-by-step algorithm to perform hypothesis testing, so we can identify 4 general steps. First of all, have to look to data and decide about general statistical model. Then we have create statement, null and alternative hypothesis. So it may be a little bit complicated, but we must understand that assumption we must provide before we will perform any kind of calculation. Then again, we have to look in data and decide appropriate statistical test within given general model. Only after that we will be able to compute some statistic test and get significance value, also call it p-value, and depending of what kind we will retrieve, like p-value less than so-called critical alpha level, which is 95% or 99% within modern time. Depending to what kind of, if this condition met, it's like at left side we have, depending to calculated value, we can accept or reject null hypothesis in favor to alternative. But if it doesn't have enough significance, which in fact happens very often, we will not be able to nor reject nor accept null hypothesis, not do nothing with alternative. It's like failed state, it's like situation when we can't provide some final conclusion. We just have to report that there is no enough evidence, so that right outcome at right side. Now we need how we can determine general statistical model. Again, we refer to type of data, categorical or continuous data. For categorical data, we have to compare proportion in groups, depending on how many groups do we have, 2 or more. For example, we can use chi-square test. For continuous data set or discrete data set, discrete samples, so continuous data in origin refer to discrete data set, we have to compare descriptive statistic parameters in group. Not only means or medians, but major descriptive statistic parameters. And depending how many groups do we have, 2 or 3, and then depending to distribution data type, normal or such kind that deviate from normal, we have to use few specific tests, like test statistics or Wilcoxon test, depending of normal or abnormal data sets, or for 2 groups or 3 groups, we use analysis or variances, or another test. So it's actually only like partial flow chart, because full will be too complex to be displayed on the screen, but we can use some tables which is available also in the practical classes material for classes 6 and 7, and it represent okay, here is, we have only 4 general cases. Left column represents that 4 general classes of practical task. Second column from left refer to proper and possible to be used general statistical model or statistical representation of this task. In practical class material for topic 7, you will find 6 more larger version of this table, which contain 6 practical approach, practical classes of task. Again, depending on our data, depending to aim of our study, what do we have, like comparing, is it we have control and experimental sample, or comparing the sample before and after experiment. We talk about comparing two independent sample mean or two dependent sample mean. We refer to data that I already has been used for illustration. If we talk about that, we have like 41 patients in two groups, and we refer to group A as control, group B experimental. We will talk about comparing control experimental group. But if we talk about that observation on the same patient before and after experiment, for example, before and after taking medicine, but it's exactly the same fast patient for each one row. So it will be that case when we talk about comparing sample data before and after experiment, and statistical representation of a task become different. First case we talk in comparing dependent sample mean. Second time we talk about usage of dependent sample mean. And if you look at the right side of this table, so you have to be obvious that different methods have to be used, different statistical methods have to be used in this case. It's only for situation when we compare two variable, two group. At the middle of the table in third column, given list of additional conditions which have to be tested, and every time it's distribution test. So we must perform statistical analysis and determine in one of available way, provide answer if our data normally distributed or not within samples. And for comparing control experimental sample, we have extra test for variances, but we can bypass it, and we come into only one appropriate method. Again, why so complex? Because all this statistical hypothesis testing method, it's actually, in fact, if you refer a statistical textbook, you find that all this it's formula. So with data and formula and spreadsheet, we can calculate result without any problem. But if we fail to choose proper test, our calculation will be just uninformative and totally wrong. So again, with our modern techniques, with our modern computational capabilities, it's just becomes very easy to fall into errors. Some other steps for perform hypothesis testing. First of all, it's state of hypothesis. So it's like pattern. Here I propose pattern which will speak about null rotative hypothesis. In blank space, it's need to provide name of descriptive statistic parameters like dependent sample mean, variance, or so. Then rejection criteria or alpha level or critical value. Typically, we take 5% or 0.05. So how different the parameters and statistics must be before null hypothesis can be rejected. And here is how we can provide some assumption about rejection of null hypothesis in case of single left-tailed hypothesis testing. So we have assumption about population mean equal or unequal for a given data set, and if our calculated criteria value fall into rejection area, so less than null hypothesis, we have to reject null hypothesis in this case as inferior to alternative. For two-tailed test, we split rejection area by 2, like given and on the following chart, and provide and check both sides for positive and as well as negative value of calculated statistical coefficient. All three left-tailed, right-tailed, and two-tailed tests assumed at this one slide, and you can determine that our case null hypothesis spoken about that our compared value are equal, so population within both sample population our descriptive statistic parameters equal. In this case it's denoted as population mean, but it will be absolutely the same for sample mean or variances or other. And alternative hypothesis talking about for two-tailed tests that parameters does not equal and not consider greatest smallest case. And one-tailed test we can assume is that our test sample have greatest or smallest our value when it is important. So when we reject null hypothesis, we come that it's enough evidence to infer that alternative hypothesis is to fail reject. We conclude that there is not enough statistical evidence to infer the alternative hypothesis to. That not means that we have proven that null hypothesis is true. We just does not have enough evidence, like I one time already mentioned in this. And it's we have failed under this with type 1 and 2 errors, which is very bad in term of problems. So here is we have like a flowing chart which show for us when we have correct cases, it's square in gray, and we have when we reject correct null hypothesis, we got so-called first type 1 error, and we fail to reject false null hypothesis, we got so-called second type error. Reason for this given at the following slide, and for example, if it could reject null hypothesis, the published paper and say the memo really different or new treatment really better than old, and it will be not true or our evidence was calculated wrong way and so on. So that's called type 1 error. And only happen if you reject null hypothesis and conclude that something is happened when in fact it's not happened, or may happen, but not in all cases. And we can make a mistake and fail to reject null hypothesis when there is really different. That's called type 2 error. So difference happens when difference is so small it does not matter much, or it's very hard to detect, or difference is big enough to care about, but sample size was just too small or not representative to tell you that much, and informative null findings. So just for fun, we can see type 1 error and type 2 error in this way, but in reality, it's actually, I think, never happened, and it's very difficult to determine real situation when we made mistake about type 1 and type 2 error. And to get closer to conclusion about hypothesis testing, we must also take into account again p-value or significance value, and how we can provide our conclusion regarding to given significance value, which typically we obtain from our statistical analysis software, along with calculated value of the hypothesis testing criteria. And here is if we have like significant less than alpha, fast and third row, we talk that we can conclude that our difference statistically significant. That's our result is statistically significant, no matter available difference or not. In case if p-value greatest than alpha, it's like second and fourth row in this table, we must conclude that our result is not statistically significant. It means that we just can't provide sufficient answer. It doesn't have sufficient evidence to provide conclusion. So it's obvious with the following chart, which show for us that up to 5% we have enough evidence, and above it, it's weak or even no evidence about our conclusion. If we talk about, again, back to our software solution, so in spreadsheet like Excel, analysis toolpack could help you with performing hypothesis testing calculation. In fact, you can do it even without analysis toolpack because, as I said, each statistical hypothesis testing method referred to us as formula in statistic textbook. So if we have formula and have data, we can perform calculation. But with analysis toolpack, we have some few methods which can give for us solution for Fisher test for variances, students or test statistics sample test for mean. And I think it's time to show example, like we have just a few minutes before lecture will be finished. Time of lecture will be finished, and just like first of all, how we can prepare our data for analysis. In this slide show for us another sample data that I already present, but I will do it even for this data. As you can see, we have to prepare some assessment like skew, kurtosis value to get a conclusion about distribution type, and then we can calculate statistics, different type of statistical hypothesis testing assessment criteria, like Fisher test above and test statistics below. As we can see, dialog very similar. We just have to provide arguments under same rules, some rules, and we will get some data like given here. So in this specific case, when we compare blood parameters for male and female, we assume that we deal with two independent data set. So and both data belong to normal distribution. Fisher test show for us that there is no enough evidence to talk about that variance is significantly different. But also it doesn't have evidence that they are equal. For sure, we have absolutely different variance value, arithmetically different. But when we perform statistical hypothesis with given probability, we can talk about they are equal or not. So in this case, F statistics give for us value 1.08, which is less than F critical. And it's allow for us to assume that probably variances have to be statistically equal, but significance level much greater than alpha, much greater than 5%, and we just does not have enough evidence to provide our conclusion. In contrast, test statistics, which is actually a major way to make the assumption, and talk about is it we can assume that mean are statistically equal or not, despite they arithmetically different. We have test statistics equal 4.07, which is significantly greater than the critical to tailored, because we are looking for just for simple difference, and it's our chart to tailored test chart show at the bottom. So test statistics significantly greater than T critical. Our first assumption that we have to reject null hypothesis in favor to alternative, and p-value, which is 0.303, which is extremely low than given 5%, means we have enough evidence. Difference is significant. Different means is significant. Okay, how to perform same analysis for our data? Let me back to table which give for me ability to pick up correct method for hypothesis testing. So first of all, I want to decide what kind of practical task do I have. I assume that I want to compare without parameters for different group of patients. As I said, it's different group of patients. So in this case, I will deal with comparing control experimental sample mean. Comparing control and experimental sample, which give for me comparing independent sample mean statistical model. And I have to create statement of our hypothesis, which null hypothesis will tell me there is no significant difference in independent sample mean, and alternative will tell that there is present significant statistical difference between means in these both independent samples. So next question, I have to check distribution type. Is it normal or abnormal? For sure, I can use like mentioned above rules about standard deviation, but it's a little bit hard to determine. And I already have descriptive statistics, skewness and kurtosis value, which is more than enough to provide conclusion. I have just to compare it with my critical value and assume that distribution for group B already. I will not provide critical value right now. You will find it again in practical classes material for class number 7. And when you will study it for sample size 41, it has to be obvious that skewness kurtosis for group A will be definitely lie below given critical value, and for group B it's only this one value which is slightly above actually outside of range of normality. So with we can accept hypothesis, we can accept assumptions that distribution are normal for both sample data set. So when we refer back to this table, we have to perform variance test as they are equal or not. And in this case, for me, will help Fisher test for variance from analysis data part, but before it, I have to check where is greatest variance, because order is matter for Fisher test, and first variable will be provided those which have greatest variance value. It's variable B. I will just start data analysis, Fisher test for variance, and use group B as, I'm sorry, I think it will be more efficient right now. Use group B, whole data, and variable 2 will be group A. I have labels in first row and output range. Okay, I will provide results at new worksheet. Maybe no output range. It will be again my sheet 1, and I will start somewhere here. Okay. Sorry. Okay, new worksheet. Так. So it will be better. It will be better. Okay, in this case, I have Fisher test value, which is 1.9, which is greatest F critical. So it's tell me that variances are does not equal. And when I examine p significance value, I see that it's smaller than 5%. So my answer is have enough evidence. I have enough evidence to provide this conclusion. Variances are really statistically different. Okay, in this case, when I again back to this table, I have to use test statistics without homogeneity of variance. Only this one method is correct in this specific case. Let's do it. Test statistics. Assuming unequal variance. Here is this one. Again, order of variables less significant right now, but okay, I get back. Would be fine to use that variable which have greatest mean. It's variable a this time. To avoid negative value, minus value. Again, unequal variance. Okay. Again, I have variable a. It's working only if you have no other data in columns. Practically, for sure, it will be much better to use range. It will be much more correct. Like this one, I prefer. Actually, it's much better to use this way. I have labels, and again, results will be at separate new worksheet. And here is this one. So let's assume result. We have test statistics 2.68, which is greatest than critical detailed. And we have significance level far less than 5%. So again, we can provide conclusions that we have to reject null hypothesis in favor to alternative. As you can see, technically, statistical calculation in spreadsheet, it's extremely easy. But major problem, it's provide all necessary assumption and choose correct method of hypothesis testing and not made any mistake in sequence of analysis. Thank you for your attention, and we will continue with other question of this lecture at next session.